Okay guys, hope everybody's doing well. Today I wanted to show you real quickly how to find the centroid for a complex figure. So let me walk you through what I've already done. This is the same problem you'll be walking through, so you just kind of want to fill out as I go along. Set up figure 1, figure 2, and figure 3. This is figure 1. Figure 2 is right here, that's the semicircle, and then figure 3 is this rectangle at the bottom. I found the centroids for each one of these. For figure 1, the big rectangle here, it's very simple. It's 2 inches tall by 2 inches wide, so the centroid is going to be 2 divided by 2. Just give you 1 inch for the X bar and for the Y bar. And then figure 2 is a semicircle, so we know that the X bar is just the radius, which is 0.625. And then I use the formula 4 over 3 pi is equal to 0.265 inches. That's going to be, if you were to come down here, and it would be somewhere 0.265, somewhere like in here, then the other one would be there. And then figure 3, subtract 1.375 or 0.65 from 1.375, and that gives you 0.75. So your width of this figure is 0.75 inches. And then we know our height is given right here, which is 0.5. So the centroids for these are going to be, I forgot to write that one in, 0.375 inches and then 0.25 for the Y bar. Make sure you're showing your units along here, and then next you find the area of these figures. Well, this is 2 inches by 2 inches for figure 1. So that's 4 inches squared. For the semicircle here, it is a semicircle, so it's power squared divided by 2, and that should be minus 0.61 inches squared. And then for this figure, it's 0.75 by 0.5, which is going to be 0.375 inches squared. Let me clean that up so there's no confusion later. And these are negative areas, so it's really important that you remember these are going to be subtracted out. Make sure I can still see everything through the camera here. Okay, so now what we do is we go to the bottom to this chart, and this is where things look confusing, but it's really not too bad. So we need to find the y sub I, and the y sub I is the centroid from the common origin. Oops, I may have gone off the page there. Nope, you can still see it. And then the x sub I is going to be the same thing. And here's our common origin. They've actually marked it for us, which is really nice. This figure is fairly symmetric, so you can kind of see what's going on. We don't have any triangle shape, so we're just going to start from right here. So if we go figure 1, which is the big one, y sub I, well, that would be up to right there, which is going to be 1, and we found that up here earlier, so we put 1 inch. I'll tell you what, let me switch to a pen. I'm not sure you guys will be able to see that. Yeah, it's not too bad. Figure 2. Now this one's a little different, and you've got to go here all the way up to wherever the centroid was. So you'll take 2 and you'll subtract whatever the centroid was, which was 0.265, 0.265, and that's going to give you 1.73 or thereabouts. And then for this one, the centroid is, we know that it was 0.25, so if we go from the origin up, it's going to be 0.25. All right, we know our a sub I. So the area of the big figure is 4 inches squared. For the small one is 0.61 inches squared minus, and then we have another negative area here, which I know seems strange. Okay, and then we're going to find the product of those, so we'll multiply those through. That's going to give us 4 inches cubed. That's going to give us minus 1.06 inches cubed This is going to give us minus 0.09 inches cubed. I'm working off an old sheet, so let me just check that real quickly. Because I've not looked at these figures for a while. Make sure that's right. 0. It's really 0.094. All right. So all that looks good. And so this spot right here and here, we need to add these up. So this is going to give us 3.02 here. So if you take these figures and subtract them from 4, you're going to get 3.0, it's just 2 squared. And then if you do it over here, you're going to get 2.85 inches cubed. All right, so we need to do the same thing at the bottom. This is tough. X bar to the center of figure 1, 1 inch. X bar to the center of figure 2, 1 inch. That one's even written up top for us. X bar to the center of this figure, 1 inch. Well, that's easy. We know our areas, those haven't changed from top to bottom. Okay, products of these, the only one that's going to change should be the second one, and that's going to be 0.61 inches cubed, and this one should be the exact same thing. Nope, this one also 0.375 inches, and that's because this is different from the top one. All right, the difference between those, 3.02 inches cubed, 3.02 inches cubed. Now, you should start to kind of notice what's going on here. Let me move this paper up real quick. All right, so we have all these values now, and all we have to do is plug them in. So for our y bar, we take the sum of the products of y sub I, a sub I, 2.85 inches cubed. Sorry, that's a sloppy 5. And then the area here, sum of the areas is 3.02 inches squared, which is going to give us about 0.94 inches. And your exponent rules for a quotient there. And then we have at the bottom 3.02. You should see where this one's going pretty quick. All right, so our centroid is from here. And move it back down. It was 1 over, so we know it's got to be right in the center, and then it's 0.94, so it's nearly at 1 over. You guesstimate it's going to be a little bit below center. And that's because we've lost a bigger amount of area from the top than we did from the bottom here. And that is all. Hope that was helpful. Have a good day.